to Operations Management course. The topic of this lecture is linear programming. Here's the third topic, that is graphical solutions of linear programming. One of the most common linear programming applications is the product mix problem. Two or more products are usually produced using limited resources. The company would like to determine how many units of each product it should produce to maximize overall profit given its limited resources. Let's look at this example. Assume that you will produce only two products, either iPad or iPhones. Here. With fixed resources in labor, facility, and time, you are asked to determine the efficient number of iPad and iPhone combinations. Yes, it is quite generalized assumptions, but the power of linear programming is in the simplicity. We can simplify the resources and constraints and profit and seek to find the scenarios that will help make good decisions about quality, process, inventory, and capacity decisions. Now we can create the linear programming objective function in terms of x1 and x2. Since this is about profit, the objective function is maximizing profit. And we learned that $7 for iPhone and $5 for iPad. So we are going to add $7 times x1 plus 5 times x2. Our next step is to develop mathematical relationships to describe the two constraints in this problem. One general relationship is that the amount of a resource used is to be less than or equal to the amount of resource available. So we have done objective function, and then we need to spell out all these constraints together. First constraint is electronic time constraint. Electronic time, from the previous information, we found that it takes 4 electric hours to produce x1 and 3 electric hours for x2. And the total electronic hours that we have is 240 hours. So the first constraint, electric time constraint, is set up like this. 4x1 plus 3x2 has to be less than or equal to 240. And the second constraint is hours of assembly time. And we also learned from the previous table that it takes 2 hours to produce x1 and 1 hour to produce x2 in terms of assembly time. 2 hours for assembly time for x1 and 1 hour of assembly time for x2. And the total assembly time we have is 100 hours according to the table. Therefore, the second constraint equation is 2x1 plus 1x2 is less than or equal to 100. Once you find out all the constraints, then the next step is to draw constraints on the graph. It can be used when there are two decision variables. When you have more than two, say 3 or 4, we cannot draw it on the second dimension, and we need to use computer programming to draw that and find the solutions. First, when you have these two decision variables, plot the constraint equations at their limits by converting each equation to an equality. The second thing that you need to do is to identify the feasible solution space. And the third thing is create an isoprofit line based on the objective function. And last step is move this line outwards until the optimal point is identified. And let's practice this together now. Now, let us look at graphical solution. On graphical solution, we need to draw the constraints and try to find the feasible region, and then find out which part or corners will produce the best point. That's what we need to do. So first thing that we need to do is that we should plot out that constraint. To plot out a constraint, we first need to figure out where the intercepts are and how to find these intercepts. Here's the constraint and intercept here. It's quite simple. Intercept is, for example, x2 intercept is 80 here. The intercept can be solved by plugging 0 into x1. So intercept when x1 is 0, what is x2? That's intercept. So when you have a constraint, plug 0 into x1, then you will find the intercept for x2. If, on the other hand, if you want to find the intercept for x1, then what you need to do is you plug 0 into x2 and solve for x1, then you will see the intercept for x1, in this case 60. You can do the same thing for the second constraint. Plug 0 for x1 and find x2, and the same thing for x1. Plug 0 into x2, then when x2 is 0, what is x1? That's intercept. If you find that intercept, now you want to look at the feasible region. Notice that in the constraints part, we said those are less than equal to, right? It's not greater than equal to. Therefore, it has to be below area, and the common area is this shaded area. And this is feasible region where any possible combination of production can take place. Now that the feasible region has been graphed, we can proceed to find the optimal solution to the problem. The optimal solution is the point lying in the feasible region that produces the highest profit. Once the feasible region has been established, several approaches can be taken in solving for the optimal solution. The speediest one to apply is called the isoprofit line method. So we have found this feasible region here, and we want to employ isoprofit method to find the best solution. And to do so, what we do is you can use that objective function here. So you put objective function and just forget about this 210. That's just an arbitrary number. And 7x1 plus 5x2 is the objective function. And to find the optimal point, what we do is we put any arbitrary number here and try to start from the below, maybe from this origin, and then go up one by one and try to see where the best point might be possible. Especially pay attention to these corner points, and among these three corner points, which one might produce the best solution or profit for this problem. That's what we need to do. So here we put a number like 210, and we see that this is the line for 210 equals 7x1 plus 5x2, and we gradually increase this profit number, and then we have a above area, and then draw more isoprofit line, and we see that in this slope, when we increase the isoprofit line and move it upward, you see that there is one isoprofit line here, and one over here, and then one over there. So among these three corner points, we see that this one will produce the highest profit. Therefore, we can identify that this point where these two constraints are intersecting together is the point that maximizes your profit. So in isoprofit line, by using the slope and arbitrary profit, you can find which point would produce the best solution for your problem. So optimal solution is x1 is 30 and x2 is 40. And this solution can be found by solving simultaneous equations for this constraint A and constraint B, and, solve for it simultaneous equations, and you will be able to find x1 and x2 values. Another method that we can use is just using corner points method. So instead of using isopropyl line, we can just try to find these corners 1 and 2 and 3 and 4, right? So 0, 0, that's origin, and 0, 80 is the coordinate of number 2, and number 4 is, I think, 50, 0, that's number 4, and the number 3, if you just solve these two constraints, you will see that that has the certain coordinate, and plug this coordinate into the objective function and see which one produces the highest profit, and the point that yields the highest profit is the solution, and you want to choose that combination of products for your production. So that's how you are going to approach corner point. In my opinion, isoprofit is faster than corner point method, and I would encourage you to use isoprofit method. If you struggle with understanding isoprofit method, then just go with the corner point method, that you draw the constraints and find the corners correctly, and sometimes 4, sometimes 5 or 6, and find those coordinates and plug them into your objective function and find which one maximizes or minimizes your objective function. And in the way you can find it. It's a long way, but it's certainly a doable way. So in summary, we have learned linear programming. This module introduced a special kind of model, linear programming, to you. Linear programming has proven to be especially useful when trying to make the most effective use of an organization's resources. The first step in dealing with linear programming models is problem formulation, which involves identifying and creating an objective function and constraints. The second step is to solve the problem. If there are only two decision variables, the problem can be solved graphically using the corner point method or isoprofit method. If there are more than two variables, then it's the time to rely on a software like Lindo or Lingo or Excel. With either approach of using isoprofit line or corner point method, we first identify the feasible region and then find the corner point yielding the greatest profit or least cost. Linear programming is used in a wide variety of business applications, as the examples and homework problems in this module will reveal. I hope this lecture helped you to understand linear programming better. Thank you very much for your participation.